What's up, everybody? Welcome to another installment of the Aftershow. Tonight's topic is on space. We're going to discuss whether or not it is actually real, because some, like Peter Leon and Iger, would say that it is not real. I very strongly disagree with that. So I'll give, some of the evidence. I'm going to do some Google researching, share the screen, and then basically research this together. And I don't know like a lot about outer space in general, like astronomy, but it's fairly easily accessible on the internet. So that's the avenue we're going to kind of take today. I also want to look at a biblical perspective and then get you know, the whole other side, which hopefully Peter will be able to address. I don't even know if he's waking up yet, though. I sent him a DM on Instagram, though, so we'll be getting this started very shortly. Don't forget to like, share, and subscribe to the channel if you haven't already. I guarantee you by the end of this video, your head will be spinning and your mind will be bending. So don't go away. I'll be with you momentarily.
Even if you are not ready for the day, it cannot always be night.
Sir, flex I do work. Work 6 of 'em like Mike. He's out of sight. Whoa, you done got me pipe. 2 man like Ike. 6 out the spot.
Into the night.
Yeah, I'm shaking the drop. I'm still up on top. I been had the bop. The devil my op. Can't pay me to stop. My God at the top. We gon' praise our way out the grave, dog. Living, speaking, praise God. Walking out the graveyard, back to life. I serve, follow your word. See with new sight.
Into the night.
I don't see Peter on here yet. Scaring me. I don't want to do this without him, but so happens a part of my Rogers County science curriculum collection, K through 12. We have a high school Earth and Space textbook collection. So you have part of the series is on Earth and part of it is on space. So this is the Exploring Space edition. So let's see what this textbook has to say about space. Now, first of all, it's a disclaimer. I will say that most of this textbook is definitely true. Okay, like 90% of it is facts, but there is going to be some assumptions and some things that have to do more with forensic science that can't, that they're not reliable on things that are directly observable, which is what really science means, and that's what the first principle, the first step of the scientific method is, to be able to test something, to be able to observe it. So anything like that that's non-observable is really put in the field of, theories, respected theories, but that doesn't necessarily mean that they're true and they're always subject to change, but facts are not subject to change. So I think that a common fact would be that space, exists outside of the Earth's atmosphere and it is a vacuum. So let's explore this a little bit. In this one, I haven't marked anything. So we'll just be kind of going off the cuff here. See what I want to focus on. You got stargazing, polar night, midnight sun, phases of the moon, motion of the moon, eclipses, beyond a shadow of a doubt. Let's see, gravity and the unit. That seems like a good one. Page 7030. So here's a picture of a guy in space. All right. He's got like some oranges or something. All right. So now there are some videos out there, which Iger and Peter like to bring up, and like NASA bloopers. That's what they call them. So like you'll see like a pin falling in the background or something, and then you can also simulate what it's like to have weightlessness if you're in water. So like total submersion water, you get that floating experience, which is what it's like without gravity. Because in space it's a vacuum of air. It's a vacuum. There's no air and there's no gravity. So that's why these things are floating. They're actually not floating. They're falling at the rate like many thousands of miles per hour, because they had to be launched into orbit. Okay, so everything is falling around the Earth it's in a circular orbit, so, or whatever orbit that the Earth has. I can't really remember the exact orbit, but it doesn't matter. I think that that's a legit picture. I mean, maybe it's not. Maybe they just did this for educational purpose so that they could have this in the textbook. But then, why not just get a real one? So, uh, maybe lack of funding or lack of time. You need something immediate, or you want to make it. You want to exaggerate what it's like to be in space, and so you'll put it in a simulation to make it, more like a movie or whatever. So it's, I don't know. But anyways, gravity, let's see. It says Olivia asked her friends what they know about gravity in space. And this is what they said. Get that off there. Gravity is a force that does not exist in space because objects float in space. The Taylor kid thinks that gravity is a force that only exists on surfaces of planets. And then another girl, Juanita, gravity is a force that exists between all objects that have mass even in space. And then which friends do you agree with most? Why do you agree? Well, is gravity real? Is one question that could lead us off into many rabbit trails. But, does it exist in space? Is another. So, according to Flat Earth, there's like a dome. So if you could get out of that dome, it's that outer space, or is that something else? They disagree that it's outer space. They disagree that there's even meteors and comets, that everything is within the dome, including the sun and the stars and the moon. Like everything is like within the layers of the atmosphere that we have today. They don't think that space is out there. But if it is, does it have gravity? And obviously not, because these guys are like basically not dropping. Anyways, gravity in the universe. Let's see if I can find something else here. What goes up must come down. Have you ever dropped your books while walking to your classroom or bounced a basketball in gym class? What keeps you, your books, basketball, everything else on Earth? Now, some would argue it's magnetism. That'd be the flat Earth model, because in their model there is no gravity, right? I don't know why, but it's just not there. They don't believe in gravity. So I don't know if that's all flat earthers, but I know most of them. Generally, it's not something that they agree with. They think that this gravitational force is actually magnetism, but those two are completely different. I mean, you have, you have to have things that are magnetically attracted, first of all, to make that happen. Like our bodies are not magnetically attracted to, like the rock that is under us is not like, there's no reason why we should stick to it. They have some arguments which I'm really not familiar with, so I won't speak on them. But let's see, the strength of the gravitational force between objects. If you move the sun in like half the distance to the Earth, it like quadruple, like several times over the gravitational attraction of the two objects. So you bring, object in half the distance, and then it's like the inverse square law is what they call it. And I don't really know all the technicalities of it. I'm not really smart enough for that. But the point is that you bring things in closer, and the gravitational attraction, increases many times. It works with, the moon getting closer, gravitationally attracted to the Earth. And it also works, with girls. You just get too close and, things happen. So eventually you're in contact. But that's gravity. Now, you can't give me like a jar of gravity. Okay. You can't give me a jar of gravity and paint it pink, like color it like, Give me a jar of gravity. I want to see that because I've not seen it yet. So it's an unseen force, but it does work. You put things out in a vacuum of space, and they gravitationally attract. They just, when a larger body, uh, uh, when a large massive object out in space, like an asteroid, for instance, gets far enough away from the Earth, well, then things start to be less attracted to the Earth and more attracted to that massive body, like the asteroid. And so clumps of other dirt and rock will then accumulate, and that's how you can get an asteroid or a comet or a meteor. And go back to Fountains of the Great Deep seminar, part 5, and we discussed that just recently, Wednesday night. And Iger and Peter were here Wednesday night. I don't know where they are right now because they both said they would be here. Maybe they're sleeping. It is 1 in the morning. Who can really blame you? All right, so, and then you got Newton, and he basically put it into technical details. The moon orbiting the Earth and not the sun. You have the sheer mass of the sun is like I don't know, it's at least twice, I think, I can't remember exactly, but it contains the weight of like 98% at least of all the mass in the solar system. The sun weighs nearly just as much, if not more, than that. So it's a massive ball of gas, and because of that, the Earth is attracted to it, so it orbits. It's a circular orbit, and we discussed that in part 5 of the seminar. Also, if you want kind of details on that, you just you have a picture of a cannonball on top of the Earth, and you shoot the cannonball, but then the cannonball falls back down to the Earth. If you shoot it fast enough, it'll go outside of the Earth's atmosphere, and it'll begin to just, if you can launch the ball fast enough, it'll just go all the way around the Earth and it keeps falling. So it keeps falling over that horizon. It's going so fast. It's a little confusing, I guess, maybe to some, but the object is to just launch something so fast that it falls endlessly around the Earth, and that's called an orbit, and that's because of gravity. Now, the reason a flat Earth model would suggest that gravity doesn't exist is because they don't think that things are orbiting around, like they don't think the moon is orbiting around the Earth. They think it's in the dome. Okay, they don't think that the Earth is orbiting the sun. They think the sun is orbiting the Earth, but it's within the Earth, actually. So it's quite crazy, in my opinion. I wish that Peter, somebody would jump on here. Let me make sure that he hasn't responded through an Instagram. Because okay. Well, he's not coming, I guess. And I don't see Iger either. All right. Well, let's see. So this is stuff on solar system formation and structure, which is totally bizarre. Yeah, there's some good stuff in here. Or I don't know. I probably shouldn't say good stuff, but definitely juicy, propaganda material that's fun to debunk, because it leads people to war to strengthen their faith. The solar system, they say, formed from a rotating cloud of gas, ice, and dust called a nebula. Gravity caused the cloud to collapse inward. Because the cloud was still rotating after the collapse, it flattened into a disk Gravity pulled gas and dust toward the center of the disk, forming the sun. And next, the planets began to form as gravity pulled these particles together. As they collided, they stuck to each other and formed larger, unevenly shaped objects. These larger objects made more mass, attracted more particles, eventually enough collected and formed Earth and 7 other planets. The leftover larger particles formed into moons that orbit the planets. Asteroids orbit the sun in the asteroid belt, while meteoroids, dwarf planets, and comets orbit the sun in their own paths through the solar system. So here we see, you start out with like a big bang, okay, and you have a big disk that forms. You got these the Big Bang, okay. Everything comes together into a disk, forms a star. The star explodes, produces these other elements that then cluster together and form planets, like the Earth. And so this all takes place over deep time, and there's actually no method upon which you can do this. For instance, planetary formation. In what world are they living in, where a star explodes and just flings all this stuff everywhere into the vacuum of space, where there's no gravity, nothing to slow it down? It's just going to, if you launch a rocket into space at 1,000 miles per hour, it's just going to keep going at 1,000 miles per hour, and it's not going to stop. So what is going to bring these planets together? What would cause a star to form? You get the star to form, right? And then, yeah, you could have like planetary formation after that. But first you have to get that massive object started to where things can orbit around it. Other things are gravitationally attracted, smaller bodies. But a star is not a star. Has to come from the Big Bang originally, the helium and hydrogen, and it's like these super light, the lightest elements that there are, and they're going faster than the speed of light into the vacuum of space, and somehow, they just find themselves together. Even Stephen Hawking said, with the universe the way that it is, it seems to be designed, because it's, how can you get a star to just form by itself? What is pulling it together to make the successful nuclear fusion reaction? What's happening here? Why are all of the galaxies spiraled into like a black hole? It seems perfectly designed. So it doesn't seem logical, that nothing would explode and produce all of the matter in the universe. And then even if you could get that to happen, it doesn't seem logical for it all to just cluster together in planets and stars, because why would that happen? Unless, some unknown force just randomly starts pulling it in, but that's not what we see today. We just see a bunch of galaxies, and everything's already been started. All the stars are already formed, and they're all spiraling into this black hole. So that seems to be the design of the universe everywhere. And what could have evolved that, and why isn't it happening like even more today? Why aren't, like other universes or something, we born into our universe? But anyways, it's definitely not based on any observation. You've never seen nothing explode, never produced a successful nuclear fusion reaction, which is what a star is, never been done in the laboratory. So it says on the next page, History from Space, from the American Museum of Natural History. More than 4.5 billion years ago, the planets of our solar system did not exist. Instead, a large disk of gas and dust called the solar nebula swirled around a young sun. How do the planets and other objects in our solar system form from the solar nebula? So, according to them, our solar system didn't exist 4.5 billion years ago. There was just a large disk of gas and dust. and that was swirling around a young sun. And so, just 4.5 billion years ago, nothing explodes and then produces this disk. And then, that eventually forms our sun and the planets. So that's just one aspect. After the Big Bang, all these parts fly out, and then all these stars are formed and they explode, and more parts fly out. It's like, but I think that they're suggesting that after the Big Bang, our solar system was formed sometime after that directly. The material from that explosion then produced our sun, which then, like, I don't know what's happening here. Honestly, like I said, I don't know a lot about it, but they're trying to suggest that over, you know, billions of years, our solar system was formed. Uh, I think the Big Bang is 13.5, so this is many billions of years after that our solar system forms. So the physics behind it is accurate and it is factual. That things cluster together. Gravity, is a factual thing. Uh, the formation, like we discussed in part 5 of the seminar, the origin of comets, meteors, and asteroids, a loose collection of rock and dirt and ice, that develops into a mass in space because smaller bodies are being attracted to it. That is physically possible, but for it to happen uh, from star formation, because planetary formation is a direct result of star formation, you would have to achieve a star formation, and it's just not possible. Well, it's never been done as of yet. Let's see what else I got here. Shows different pictures of the galaxies, the Virgo cluster. Um, you zoom in to these dots, and then these dots develop into like multiple galaxies. I'm not really sure how you could explain just trillions and trillion. Each person could own 11 trillion. Is the math? There are so many stars. Each person could own individually 11 trillion to themselves, and so to have that many stars just within like a dome seems to be totally bizarre to me. It's completely ridiculous. So since let's see, anything else we want to address on that? So you can't have something from nothing. Okay, you can't have a stellar fusion process occurring for no reason. It doesn't happen today. Nobody's ever seen a star form. Like, we see clouds of dust. Okay, we're able to open up several ranges of the color spectrum with other tools like our eyes can't see, so we zoom in with special telescopes and use computers to uh, open up the color spectrum, and then we're able to see clouds and stuff, and then you put it together, and obviously it's a computer generated image, but it's based on what's actually there, because what it's reading is different colors which represent different temperatures and different elements that are burning, or that are reflecting, whatever it may be. Like I said, I'm not like very good at astronomy, but you can see with astronomical tools, of modern science, you can see nebulas, clusters of giant clouds in space, but it cannot be proven that they're actually like forming into a star. That you see, you have the problem of dust, itself. So the spot is getting brighter. Does that mean that it's a star forming, or does that mean that there's dust clearing out of the way? That there could be things, objects in front that could be obstructing that from. I mean, you're looking at light years away through a tiny telescope on the Earth, so it's. I don't think it's very logical to say that you can see a star forming just through uh, telescopes. You'd need better than that. You'd need an actual demonstration in the laboratory to show how it could just happen. You could demonstrate it in the laboratory, but then how's it going to happen for no reason in space? How are these things just? How's all this gas that was propelled from the Big Bang just going to randomly come together and find itself being propelled that fast into the vacuum of space? It's not logical. Uh, you know and then secondly, it's just gas. So how are you going to condense it into a solid? I think that an open vacuum is just about the worst way possible to condense gas. You know, who in the That's not anywhere close to being observable to fuse gas into a solid. Never been done. Never will be done, in my opinion. So, the Big Bang and the star formation and the chemical formation, uh, you still have to have stellar evolution for planets. You have to have stellar evolution for all of the chemicals, and they're obviously they're radiometric dates for like meteors, uh, uranium lead dates that they extract from meteors and asteroid samples that come to some 13.5 billion years or whatever is like the oldest known rock sample, and that's how they correlate that with their theoretical age of the earth that they already had before that. See, because before radiometric dating comes along, you have uh, the geologic column has already been established. It's already been uh, promoted and published and often well accepted that animals had evolved according to Darwin, and that the layers they took millions of years to form. So you have an estimated, age of the earth, and also a age of the universe because of the Big Bang theory and the the total distance from what they would consider the singularity. So you just look at us and you go to the cosmic microwave background radiation and determine how far away that is, how far or how long it takes the light from the stars to reach the earth, and it's kind of how you estimate the age of the universe. And then radiometric dating would then conform to that, okay, because it's based on several assumptions, and it's more of a forensic science, which you use to corroborate other models, but you don't use it itself as evidence because it cannot be in itself be evidence. And that's more of a radiometric dating topic, I guess. But since Peter and Iger are not going to join, I don't know, we had this set up, I thought. So, I don't know. Not cool, guys. Whatever. We'll close this one down then, and I'll see you in the next broadcast coming Wednesday. Not sure what I'm gonna do. In the process of getting a new phone, so I'm gonna be hindered from like doing any documentaries or any video vlogs or basically any shorts or biblical science lessons, things like that. But I can still do live streams. So, if I don't see you before Wednesday, God bless. Stay in prayer. God bless America. My name is Christopher Sylvius. Thanks for tuning in. Peace be upon you.